All right, so for indicator 5, we're going to be talking about linear equations. And a linear equation is just an equation that when you graph it, it graphs as a straight line. And that straight line has an incline or a decline, and that's the slope, okay? Later in the week, we'll get into special cases where it's either horizontal or vertical lines. They don't have a slope because they're straight across or straight up and down, and so there's not that tilt or incline. But for today, we're going to stick with lines that do have a slope. Okay. So the definition for slope, obviously, this is not like the Webster's dictionary definition of slope. This is kind of a real life, what we're going to use in this class definition for slope. So there's two ways you can think about it. One is rise over run. You guys have heard that probably since what, 5th, 6th grade, I think, is when you start kind of getting into slope. You've heard rise over run. Now, rise over run makes a really pretty mnemonic, right? They both start with R. Rise can, when we'll see today, can actually be fall because you can go up or down. And then you can run left or right, okay? So a rise would be a positive Y, a fall would be a negative Y. So rise or fall, and then the run is left or right. Right would be positive, left would be negative, okay? And what that means is the change in Y's over the change in X's. And just the kind of silly memory trick I always say is Y's rise. So your Y's are always on top and your X's are always on bottom. And the change in Y is you go from one height of a Y and you either rise or fall to get to the height of your other Y. Okay, so that's your change in Y's. And then your change in X's, very similar to that. You've got your first X. And then you either run backward or forward to get to your next X. And so that's your change in height over your change in left and right, okay? For intercepts, intercepts are super simple as soon as you can just wrap your mind around what they are. They're a very easy concept. Intercepts are just simply where your line crosses the axis. So you've got an X-axis and a Y-axis on a coordinate plane. Where your line crosses the Y-axis is the Y-intercept. Where it crosses the X-axis is the X-intercept. Okay, so we'll do a little bit with that. All right, so in your notes for this number 3 here, it says find the slope of each line. Well, if we remember that slope is rise over run, and this will be the first case as a good example how it can really mean fall over run, but that's okay. That doesn't sound as good. So what you always do is you start with your your leftmost point. So just like when you read left to right, you're going to read these graphs left to right. So you find your point that is the leftmost point on your graph, which in this case is this one up here. Wyatt, would you flip that top switch for me? Thanks. I moved you away from it, made it hard to stretch, didn't I? So what you're going to do is you're going to put your pencil on this point right up here, and then you're going to either rise or fall to get to the other point. Well, in this case, we have to fall. So we fall 1, 2, 3, 4, 5, 6. We fall 7 to get even with that other point. So when you're writing the slope, because that's your change in Y, that -7 goes on the top because we went down 7 from the left point to get even with the right point. Then we make a turn or a corner, and then we run. And we have to count how many times we have to run to get over to that point that we're heading toward. So we run 1, 2. That was a positive run. So there's your slope, -7 over 2. Now, technically, every slope is a fraction. We don't always write every slope as a fraction, and I'll show you why here in just a minute, but every slope needs to be a fraction because it needs to be a rise over run, okay? You always want to make the fall or the rise, and then you want to turn the corner and head over toward your other point to get your run. All right, so let's look at this one. In this case, we've got, you always M equals. I had one of my classes look up why we use M for slope. It's Latin for change in latitude or something. I don't know. It was some Latin word for change in incline or decline. All right, so we've got M equals. Anytime you're asked to state the slope, you always want to start with M equals because you want to state what you're actually, M equals. You don't want to just write a random number out to the side because that's just not proper math. So the first thing we're going to do is we're going to start at our most left point. And in this case, we are going to rise 1. So we go up 1. That puts us level with our point. Then we're ready to make the corner, make the turn, and we run to the right 2. We rose and we ran to the right, 2 positive moves. There's your slope. Okay, 1/2. And if you'll notice in the first case, our line reading it left to right is running downhill. Remember, we looked at positive and negative correlation. Okay, this is a negative. This is running downhill. So our slope should be a negative, and it is -7/2. In number 4's example, our line is increasing or running uphill. So that should give us a positive slope. So when we do it, we should get a positive over a positive, or well, here we'll see in a second, a negative over a negative would also be positive. But if you look at your line and it's running downhill, and then you look at your slope and you don't have a negative somewhere in your slope, you need to, that's kind of a good checkpoint as to know that you've done it right. Okay, because sometimes people will put 7/2 and they will forget that the 7 move was a fall, and then they have a +7 over a +2, and you cannot have a downhill line with a positive slope. Okay, and I do want to show you this really quickly. If you read it right to left, which I always try to always do it the same way every time, but if you read it right to left, I want to show you something. So if we go right to left, whoops, I meant to show you this and I forgot. If we start at this right point and we rise 1, 2, 3, 4, 5, 6, 7, okay, we rose 7, and then we run, we make the corner and we run backwards, right? We run -2 because we run to the left 2. My slope is still a negative slope. It doesn't matter if the negative is on the top or the bottom. So you'll notice this way, I fell first and then I ran right. This way I rose and I ran left. Either way, I had one positive move and one negative move. Because it's negative, and remember negative correlation, one goes one way and one goes the other. So one goes positive, one goes negative. That's going to give you a negative line. Okay, so if you want to rise and fall or fall and rise and run, it doesn't matter to me as long as you remember if you run backwards, it's a negative. All right. Let's see, let's look at this one. Okay, and you don't even, this one just, we're just going to do it really quick as a quick practice. We're going to start here and we're going to rise 1, 2, 3, 4. That puts me level with my other point. So M equals, that's a +4 because I rose, and then I make the turn, right? And I go 1, 2 to the right, which is a +2 move. Now, remember, I always said reduce if possible. This is a good example of where you should reduce. 2/4 reduces to 2. Now, this is a good example of where mathematicians are lazy, because this is a fine answer. This is the way you'll see it on iLearn. You'll see it going into high school. M equals 2. That is the correct answer. Okay. But what do we know about every whole number? Is this a fraction? It is a fraction because every whole number is really over 1. So when you're dealing with slope, you've got to remember that every whole number really is over 1. And so really, even if it just says 2, it's still a fraction because it's 2/1. So if you need to graph it, you would say the rise is +2 and the run is +1. Okay. Change in Y, our Y's went up 4. That's our change in Y. Then we ran, our change in X was +2. Positive change in the Y was 4, positive change in the X was 2. Always reduce it, and I'm fine if you just leave it just like this, M equals 2. Okay. I won't count it off if you put 2/1. Doesn't matter. I just want you to get familiar with seeing it without the fraction. All right, last we've got a fall here. So we're going to fall 1, 2, 3. So M equals -3. We fell 3. That was our change in Y. Then we turn the corner and our change in X is 1, 2, 3. So we had a +3 move in our X's. And again, if we can reduce, we should clean it up. M equals -1. That's the ultra clean answer. You can put 1/1 if you want. So the slope for number 6 would be M equals -1. Okay, good on that? All right, so we're going to also look at how to find the slope when you're not given a graph, when you're just given 2 points. Notice on all of these graphs, let me clean this back up a little bit. Notice on all these graphs, we were given 2 points on the graph. And we were able to calculate our change in Y by counting and our change in X by counting. Well, here we're given 2 points, but instead of doing it visually on a graph, we're going to do it mathematically by using an equation that is the equation boils down to the change in y over the change in x. So our equation that we're always going to use here is m equals y2 minus y1 over x2 minus x1. So the change in y's is y2 minus y1 over the change in x's, which is x2 minus x1. Really get familiar with this equation because this is going to stick with us, I'd say, through 3/4 of our year. We will keep coming back to having to find the slope, okay? We will use it in multiple indicators moving forward, all right? So the first thing, I always tell people this, and sometimes I have people not do it, and it really tends to catch them every so often, is name your ordered pairs, okay? You have an X and a Y that go together. And if you start with, we'll say this point 19, -4. If we name that 19 our X1, then the Y that goes with it has to be Y1. That makes our other one X2 and Y2, okay? And it's really important that these two stay together, and I'll show you why here in just a minute. But I kind of always make a joke. It's like prom dates. If you see 4 people walking into prom and there's a red bow tie and a red dress and a purple bow tie and a purple dress, can you tell who came together? Right? The prom dates always match. Your prom dates have to match when you're doing slope, because if you flip-flop them, then it's going to mess up your slope. So if we take our equation, which is m equals, right? Now, on the top, we're going to put our y2 minus our y1. So in this instance, my y2 is a 6. My equation is a minus, so you're going to put the minus sign there no matter what. y2 minus. Now, if you look at y1, it's a -14. So use your parentheses to not lose some signs here. Okay, so that's y2 minus y1. And then on the bottom, I'm going to put x2, which I got to go back over to 15 minus 19. Now, you always want to do a quick visual check here, okay? And I'll do it in color and then I'll erase my color. What you want to make sure is that, notice I made 19 and -14 my Y1, my Y1, X1 group. They should be stacked on top of each other in my equation. You've got to keep them together. You can't put 6 minus a -14 and then on the underneath have 19 minus 15, because then you've got your Y's and X's crisscrossed. And then likewise, my purple group, my X2, Y2, they should be stacked right on top of each other, 15 and 6, okay? So now when I reduce, you know that a negative times the parentheses of a negative number, negative times a negative goes positive, so clean that up. It'll make it easier to do the math. And we have m equals 6 plus 14 is 20, and 15 minus 19 is -4, and that can be cleaned up a little bit more. 20 divided by -4 is -5. Okay, and that's your answer for the slope. Now, I do want to show you this one time. I will not do it on every problem. I just want to show you this one time. What if I flip-flop and I made my points 1 and 2 different? Okay, and I'll show you it. You're still going to get the same answer, and I'll show you why. So if I make this first pair X2 and Y2, right? I'm going to flip-flop it. And that means I make my other pair X1 and Y1. I'm going to show you how it doesn't matter. As long as you keep your pairs together, it doesn't matter which one you call 1 and 2. And here's why. So if I fill in my equation here, m equals, now I'm going to do Y2 minus Y1. In this instance, now my Y2 is -14. So Y2 minus Y1, okay, -14 minus 6. And then on the bottom, I've got X2, which in this case is 19, minus 15. Do a little simplifying here. -14 minus 6 is -20. 19 minus 15 is 4. And again, -20 divided by +4 is -5. So in both cases, I got -5 as my answer. The only difference is in the first one, my bottom number was negative, and in my second one, my top number was negative. But remember, with a negative slope, as long as one is going negative, as one is going positive, it doesn't matter which one, okay? It still is a negative slope. Now, like I said, I'm only going to work it like this once to show you that it doesn't matter. The main thing that's important is that once you call the X2, the one in the parentheses with it has to be the Y2, and you've got to keep your order straight. And again, if you look at your ordered pair here, 19 and negative 14 were together. 19 and negative 14 are stacked right up on top of each other. In the other one, you've got 15 and 6 are together as one ordered pair. And you'll notice, oops, 15 and 6 are together stacked on top of each other in the equation. Okay. Good there. All right. Let's do one more quick one of using the points to find slope just to get our practice in. So we're going to have M equals. And the first thing I'm going to do before I go any further is I'm going to name these, and I'll call this X1, Y1, and I will call this one X2, Y2. Okay. Once I have them named, I'm ready to plug them into my equation. Y2 minus Y1 over X2 minus X1. Okay, change in Y's over the change in X's. And because I put this Y first on top, this X goes first on bottom. And then I'm ready to simplify. 4 minus 20 is negative 16 over 3 minus 17 is negative 14. And again, always reduce. So how would this reduce? Anybody tell me? Yes. Okay, you can do that. You can skip a step or not skip a step. That's fine. Negative 8 over negative 7. That is correct. But what do two negatives always make? A positive. You can skip this step if you want, but in the end, your answer needs to be positive, positive, because two negatives always make a positive. Okay. And again, think of our correlation. If we had them both going up or both going down, it was always positive correlation, right? So if you have two negatives or two positives, you're still going to end up with an increasing line. Okay. All right. Now let's look at intercepts. Intercepts are super quick. Notice your instructions though. I have people miss this every year. Sketch the graph and state the coordinates. State the coordinates of each intercept. Coordinates are an X and a Y. That's a coordinate. It's also known as an ordered pair. So for the first one, the X-intercept, this is your X-axis, right? The X-intercept right here, it tells us is -3. So on the X-axis, I'm going to put a point right on the -3. I graph that intercept. My Y-axis is right here running up and down, and this tells me my Y-intercept is +3. So right on the Y-axis, I'm going to put a point at +3, and that's as hard as it gets graphing these. Okay, graphing it, you do the last step because you only need 2 points to draw a straight line. There's your graph. X-intercept on the X-axis, Y-intercept on the Y-axis. Plot those 2 points and draw your line. Intercepts will always, always, always be on an axis, okay? Don't put these two together. I have people do this a lot. They want to plot the point -3,3. Don't put this in your notes. I have people want to plot the point -3,3. The X-intercept is one separate point. The Y-intercept is a totally different point. They don't go together to make a point. All right. So notice the second half of our instructions said state the coordinates of each intercept. So for our X-axis, or for our X-intercept, sorry, our X-intercept, the coordinates, we know the X value of the X-intercept is -3, but what's the Y value of that red point? Yeah, it's 0. You'll notice a pattern here. Then if we go to the Y-intercept, okay, we want to know the coordinates of our Y point. Well, we know the Y value is +3. Our problem told us that. But what's the X value of that purple point? 0. Yeah, good. Notice the pattern. For an X-intercept, the Y is always going to be 0. Always, always. For a Y-intercept, the X is always going to be 0. It has to be for that point to sit right on an axis. Because if you look at the red point, for example, right, your X move is -3, but your Y has to be 0 because it has to sit right on that axis. It can't rise or fall. Same with the Y point, right? Our Y point, when we go to graph to figure out the coordinate or the ordered pair of that purple point, 0 is the X move. It has to be 0 because it can't move off that intercept or it's not an intercept anymore. Or I can't move off the axis or it's not an intercept anymore, okay? So if we look at, for example, this one, number 12, we'll skip the other two because I don't think we need to do 4 of these. First, we plot the X-intercept at +4. So we remember this is your X-axis. Sorry. So we put a point at +4. Then our Y-axis is at -1. And then we draw a line connecting those. There is the graphing aspect of it. And then the last step is state the ordered pair or the coordinates of the X-intercept. Well, all you have to do is take this number for the X and then put a 0 for the Y. And then likewise for the Y, the 0 goes in the X spot, and this number right here, your Y-intercept, goes in the Y spot. Make sense there? As long as you can remember the opposite is always a 0, intercepts are very easy. Now we're going to take that concept and we're going to run with it into this next section. And if you got to remember the rule that the opposite is always 0. Oops. So for number 13, we want to find the X-intercepts for each equation and state them as an ordered pair. Okay, so first of all, let's find the X-intercept and we'll find the Y-intercept, and then we will write them both as an ordered pair. So we know in algebra, if we have 2 variables, if we know the value of one variable, we can plug that in and solve for the other. Everybody good with me there? Okay, so if we're looking for the X, and I'm going to go ahead and skip ahead and just put my ordered pair spots right here just so I can fill in some stuff. For my X-intercept, what do I know about that ordered pair before I do any math? What do I know? Do I know the X value of my X-intercept yet? Do I know the Y value of my X-intercept? It's what? What's the Y value of every X-intercept? 0. So I can plug a 0 automatically into the Y spot. So if I take my equation, 4x plus 2y equals -2, and in the Y spot, I know it's going to be 0, right? So 4x plus 2 times 0 equals -2. 2 times 0 just goes away, and I'm left with 4x equals -2. Okay, now I solve for x by dividing by 4 and dividing by 4, and I get x equals -1/2. That's the reduced version. So I go back up into my answer, and my X-intercept is -1/2. And writing it as an ordered pair, I would put -1/2 in the X spot. Okay. Now I'm going to do the exact same thing, only I'm going to do it for the Y-intercept. Before I do anything, coming back to my ordered pair here, what can I put in my ordered pair for my Y-intercept that I know? Do I know the Y value yet? But do I know the X value? What's the X value? 0. So I'm going to come back to my equation. 4x plus 2y equals -2. But now I'm going to plug a 0 in for the X. So when I do that, I get 4 times 0 plus 2y equals -2. My 4 times 0 goes away, leaving me 2y equals -2. And when I solve by dividing both sides by 2, I get y equals -2. Not negative, sorry. Don't know why I said negative. That is this right here is a positive, so that's a positive. So I'm dividing by a +2. -2 divided by +2 is -1. So my Y-intercept is -1. And the ordered pair that creates is a 0, -1. Now, I want to show you something. It's a shortcut, okay? And I like shortcuts. So if when you're doing this, okay, and I always use my finger, but I'm going to use my pencil because you can't see my finger on my iPad. But if I take my finger and I put it over 4x, right? So where I can't see 4x, I'm left with this line right here. I'll circle it in yellow. Notice I'm left with this right here. If you want to skip this part right here, you don't have to write all of that out Because if you can just put your finger or just mentally block out the 4 and the X, because the X is going to go away anyway, you can start right here at this step. 2y equals -2. Because when you put your finger, let me do this. When you put your finger right here and you cover up the 4x, you're left with 2y equals -2. And when you're left with 2y equals -2, you can skip right to that and put that right here at the 2y equals -2 that I just kind of, put a little square around. Now, likewise with the other, with the other one, I can put my finger over, and in this case, I'm just going to black it out on here just to show you what I mean. I can put my finger over 2y, because when I plug a 0 in for y, what's left? 4x equals -2. I can start right here. 4x equals -2. I can skip this step because really you can do that step mentally. If it helps you to write all that out and plug the 0 in and then solve, by all means do it. But if you're able to mentally cover up the y and solve for x, and then cover up the x and solve for y, you've got your intercepts. Okay, so let's look at this one really quickly and then we will be done. And we're going to do this the shortcut way. So if I, let's see, I'm looking for my X-intercept, which is going to be a point. What can I fill in right away? Somebody tell me what I can fill in right away. Yes. Yes, I can fill in my y value right away. For my y-intercept, what can I fill in right away? Somebody else. Somebody, anybody? Yes. Yes, my 0 goes in the X spot. Okay, now I'm going to do this the shortcut way. So when I do it the first time, I'm going to find my X-intercept. I'm going to take my finger and I'm going to cover up this for a second. Okay, and obviously you're not going to scribble it out because you still need it. But now what did that leave behind? 7x equals -4, right? So when I solve for x, I divide by 7 and divide by 7, and I get x equals -4 over 7. That is my X-intercept, which means it goes in the X spot in my ordered pair. And now I'm going to do the same thing, only I am going to cover up my X this time, leaving, don't lose that negative, leaving -8, y equals 4. Okay, let me move that back over so it kind of hides that. Divide by -8, divide by -8, and y equals a positive and a negative is going to give me a negative, and then 4 over 8 is 1/2. So my y-intercept is -1/2, which means in my ordered pair, -1/2 goes in the y spot, and that is your answer. You've stated the intercept and you have stated the ordered pair. Now you can see work-wise, this right here, let me circle it in red. This right here was the work for number 15, and all of that other was the work for number 13. All I did the same thing. Uh-oh, did I do a math error? I see lots of hands. Yep, good job. I saw a bunch of hands. Come up and grab candy if you had your hand up. So the 4 was supposed to be a negative. So, yep, and I just did it in this one, right? Negative and negative, so that'd be a positive. All right, so my y-intercept should be +1/2, right? Good catch, guys, thank you. When I wrote the problem a second time, I forgot to bring that negative down with the 4. All right, but my point with the work is if you want to do it like we did number 15, that's kind of the shortened version, that's totally fine. If you need to do all the extra work like we did in 13, plugging the 0 in, that's fine as well. Whatever way helps you to see it the best, okay? Good catch on my math error, I appreciate that. That means you guys are paying attention, which makes me oh so very happy. So, all right, for those of you at home, go ahead and click load in Cami and show all your work, and then submit and email me if you have any questions.